friends, gentle alumni, current staff members, current students, people I have not seen for years, some whom I have not seen for 1 year, and a few of you I have never met. Welcome. and maybe a few I actually recognize, yes. Welcome to the DIKU Alumni Day. It's great to see you again. My name is Jakob, Simonsen. I'm the head of DIKU at the moment. My time with you today will be fairly brief. I'm going to talk for 15 minutes and then we'll get to the real meat of the matter, which is a lot of talks, both from externals and internals here at DIKU, with all of the cool things we're doing. So the plan for today, before the food, that's the bottom thing, right? Before the food, we have lots of reports about current research and other things that occupy us here. For the first quarter of an hour, I'll try to give you an overview of the state of affairs, and then we'll move on to the people who actually create value, namely Serge, Boris, Carsten, Barry, and Valkyrie, and Joanna, of course. And I think, Joanna, you will be the last person to speak today. So when Joanna is done, you basically just go out and eat and drink and have fun.
But not before.
But not before. Not before Joanna's done. That's very, very important. So it falls to me to give an overview of affairs. But first, some practical information. Toilets can be found in the basement hall just in front of the mosaics at Auditorium 1. Auditorium 1 is that way, quite a bit that way, actually. And then to the basement, and then for the toilets. If some of you are really creative, you might be able to break into the math department. They have toilets right over there, but I wouldn't recommend it. So the outer entrance door to this entire building complex remains closed. If you need to go outside for any reason, remember to get an entrance card. I think Tine is out there and can hand them out. Yeah, or ask somebody to help you get in. We are, of course, friendly with all of our alumni, and our alumni are all friendly with each other. So ask anyone, and hopefully they'll let you in. Ask Inge for help. Inge, please raise your hand. Inge is the mastermind of the Alumni Day. She'll be here all evening, and she'll be right here at the center of the front row in case you need her. The reception is a self-service buffet with seating at tables. We have reserved some tables with signs indicating various spans of years for alumni. Most of them are open to all, of course, but we indicate a few where people might want to gather, especially very recent alumni and not quite so recent alumni. So join people from your own year of enrollment. These tables or just sit anywhere. Right. So let me talk about the state of affairs at DIKU. This is going to be a very management-y talk, which means that, again, the actual value, which is typically best conveyed in a qualitative manner, that'll be done by researchers, that we'll see in a moment, and I'll just show you some graphs, because that's how managers end up thinking. But thankfully, these graphs are really great. So in 2022, we accepted 530 new bachelor students. This is more than ever before in most of the educations that we are part of. Some of you who are alumni from a few years ago might remember that we used to have only one educational program at bachelor's level, namely the computer science or Belongie program, but we have many more at the moment. We have computer science and economy and machine learning and data science here at our own faculty. We also have communication and IT and health and informatics at the Faculty of Humanities, respectively at the Faculties of Health, and we contribute about 50% of the teaching there. The positive story is we are enrolling more people than ever before, and hopefully at the end we'll also create some value for society by actually having them graduate. CS programs make up about 19% of new students at the science faculty, so about 1 in 5 new students here at the Faculty of Science have something to do with computer science. Across all of those programs, we have an enrollment of about 1/3 women. So this is more than before. but we are still trying to improve that, especially for our program in computer science, where we've been trying to push that number above 20%. And we still have a lot to learn. For instance, in machine learning and data science, we actually had a slight decrease in the number of women. We think this is because we are not marketing that educational program right, so we're going to look into that in the following years. So those are the people who go in, right? But we also have some people who graduate. And the horrible thing about using words like production and so on is that we tend to think of ourselves as a sausage factory. And that's not the way to think about people. In terms of the way that the faculty of science, the terms they use is like production. But trust me, we don't view current students or alumni as sausages. We do view you as people. So the relevant graph is over here, the rightmost one. So the purple, dark blue, purple, yeah, I'm colorblind, this is not easy, okay? The purple vertical bar here is computer science, so basically the bachelor's degree in datalogy, as we call it in Danish. And the other bands are the educations that we contribute to, and as you can see at least, we still have quite some growth in the computer science area with the bachelor's thesis or bachelor students who graduate. We also have a very steady number of people graduating from communication and IT, and we have a bit of some wobble in some of the others, but we're looking into that in order to improve it. There's lots and lots of educational programs in IT in general and computer science specifically in the Copenhagen area, but we hope to be able to increase this number to get more people into society who knows about computer science. We also hope to actually get the funding. And for the master's level, or Kent Skjent Datalogi in Danish, it is a similar but spectacularly more impressive story at the moment. We are producing more masters or candidates than ever before, and this is mostly across the spectrum, again with a bit of a wobble in some of the smaller educational programs we're contributing to. We know that our graduates are wanted, so we try to create more of them. That also creates more alumni, so that's hopefully a great thing also for you. To sustain this and to expand this, we also need to create more income. And I'm sorry if I sound not like an academic or a professor, but a bit like a business manager. But this is a modern necessity in universities. So this is roughly the DIKU financial status over the last couple of years. So the rightmost thing is 2022, our estimate for what's going to happen this year. And the sort of penultimate rightmost thing here is what happened in the fiscal year 2021. So the light purple bar is what's called ordinary income. So ordinary income is basically what we get from the government and the university for teaching. And as you can see, that is weirdly stable, even though we've been sort of growing in intake for the last couple of years. And that's due to lots of things. One thing is the government's maybe not giving a lot of money to the university, and sometimes also actually decreasing the amount of money, but also the way the University of Copenhagen internally distributes funds. So one way of offsetting that is getting so-called project income. So this is via a research project that we apply for an open competition from the European Union, from private foundations like the Carlsberg or Willem Foundation, or from government agencies. It is also income that we get when we, for instance, have targeted courses for Novo Nordisk, where we try to teach them, for instance, some data science that's hard to learn elsewhere. And we hope to get a bit more growth or stability, at least, in our finances in order to actually create more alumni. This is something where we are typically at the mercy of the government for the light purple part. So the more we increase the red part, the more independent we are. At least that's how we like to think of it. Then there's growth in staff. And let me say that it's not a goal in itself for any public institution to grow in staff. If anyone tells you otherwise, they're basically lying or have a misconception. The reason why we think that DIKU should grow is to create more knowledge and more people going into industry and into the public domain knowing about computer science and IT in general. So growth for its own sake is not something we do. We actually have a purpose with this. The rightmost column here is 2021. And as you can see, we are scaling up in the number of people. The topmost, I'm not going to say the names of these colors because I'll get them wrong. The topmost block is administrative personnel. We try to keep that in sort of same proportion to the scientific staff throughout the years, but that's of course also growing when we hire new professors and so on. Then there are external lecturers and so on in the orange part. We have had a remarkable growth in PhD students over the years. Truly remarkable. Not just because we have to, but also because we want to. We are spanning lots of areas in computer science, including very practical ones, also requiring lots of lab work and lab space where we need many people in general. And we are scaling up at all 3 levels of academic seniority, from assistant to associate and to full professors. So in case you are not completely familiar with it, assistant and associate professors are what's called adjunct and lector in Danish. So we are still growing, and we hope to do that in general. I'll be done with the growth graphs in a moment. I just very much like them because they're increasing. So there's this thing called STOKE with the wonderful Danish letter O. So this is essentially 1 year of full-time study work for one student. So the way I like to think of this is that if we take all of this, so the entire thing, including the mustard yellow and kind of black, but not really, bar up there, is that we are creating around 1,100 of these student years. The way I like to think of it is that we have one student, not many students, one student, and in time compression, we are actually teaching that student for more than 1,000 years every year. Trust me, the metaphor gets funnier and funnier when you think about it. But the point is, this is also increasing. And this is, of course, a function of intake in students, but also I'd like to think of student diligence. They are actually working. It's not just us teaching. Right. So some various initiatives that we are keen on at the moment and that we are involved in. We are part of a national research center called DIREC, funded by the Innovation Foundation in computer science, with basically every computer science department in Denmark. So for those of you who've been here a really long time or graduated a long time ago, you might remember some rivalry between East and Western Denmark. That still happens. But we also like to collaborate with them. So this is a great thing. We also, together with several other universities, have a Pioneer Center for Artificial Intelligence. You're going to meet Serge later on, and who will talk about, I think, a specific thing within the Pioneer Center. This is a wonderful initiative, also spanning computer science in Denmark. We have the Digital Tech Summit coming up, again with all of the other universities and a host of various companies in Bella Center in October 25 and 26. This is a great event with lots of talks both from industry and from the sciences, and I think there's still tickets that can be bought. In case you are interested, talk to Anders, whom I'll introduce a bit later. We also have business collaboration and innovation projects. You're going to meet the team in a moment. They are the ones actually also sort of arranging the alumni day. So they're a great bunch of people. And we are currently involved in scaling up teaching computer science to other studies, or other departments. The Department of Plant Sciences, the Department of Food Sciences. And this needs to be done in order to get digitalization out there, at least in the way that we think of digitalization. And we also do research in tomorrow's technologies. Actually, can we say the day after tomorrow, because that's a bit further ahead, right? And you'll hear lots about that in a moment from some of our great researchers. And another thing we are interested in is the diversity agenda, broadly construed from not just from the point of view of gender, but diversity in general. which has been the subject of multiple projects at DIKU at the moment, and we're also going to hear Carsten Lassen from Specialisten on Neurodiversity a bit later today. We've been a bit in the news. Let me just do this a little bit more slowly. We've been a bit in the news. We try to communicate our research, and we also try to make sure that everyone knows we're actually creating value. It's probably easy for you as alumni or students because you're kind of in it already, and you see the value of both basic and applied research. But again, in the modern political world, especially here in Denmark, it's important to communicate the great things we do. So we had plenty of stories in the news. For instance, this is not necessarily a positive story, but so our computers are sexist towards both female and male politicians. But the positive thing is that we can actually quantify this using, for instance, techniques from natural language processing. We are opening a new education together with the physics and math department here and the Technical University of Denmark on quantum information science, which is going to fly hopefully in the summer of next year. We are looking at many things. Bias and so on is really popular in the media at the moment. So taking some of the foundational work we do in machine learning and then applying it to cases that are of societal importance is awesome. And it's also something that the general public is interested in. And we have lots and lots and lots of other stories. Here's a small selection of them from various places at DIKU on many different perspectives, showcasing that we're not just only communicating things that are sort of immediate importance to politicians and so on. We actually try to cover as much of the breadth of DIKU as we can when communicating with the news. And I think that is more or less the current state. So you saw lots of graphs with things improving. This is necessary, not just for us, but also for the rest of society. And it's a wonderful story. I hope we can keep doing that. We'll work for it anyway. Now, I've spoken enough, but I actually have one more thing to say. One of the things we've done in recent years, actually during Corona, was to create a specific section, like a little organizational unit within DIKU for business collaboration and innovation. And we have Anders Pall-Schütt, who is this younger, more cheerful, more handsome version of me with the same aesthetics for beard and hair, and so on, just a lot better. As the head of it, and he has built a team of 3 full-time employees working in various aspects of DIKU's collaboration outside, not just the DIKU Business Club, but also running part of the Science AI Center, doing innovation projects and collaborating on research with industry, and also, very importantly, the Alumnus Association. So you guys, they're also in charge of it. If you meet any of these people today, just give them a hand because they're the ones that they take care of you and take care of everything tonight. But I will leave it to Anders, who before he worked here has worked in lots of places, including Copenhagen FinTech, the Technical University and so on, and is an industry veteran, an all-round cool guy. Anders will actually introduce our speakers, and he will also moderate any discussions and questions you might have. So please treat him well. In case you need me, I'll be right there next to Inge, and I'll be talking to you outside after 7 o'clock. So please give Anders a hand. Take it away, Anders.
Thank you very much. Thank you, Jakob. It was part of the job interview to have the right kind of hair dress code. So I'm delighted to see all of you in DIKU Alumni Association. Good to see all of you. And I'm here to introduce the speakers. It's going to be a very tight program. I hope we have a little time for questions at the end of the presentations. It's only 15 minutes, so it's going to be very tight. And when there's only 2 minutes left, I will raise a flag with the 2 minutes to let the speakers know that it's about time to finish up. First speaker is Belongie, and he came to Denmark in 2021. He's actually been here quite a few times before, and he's professor at DIKU and director of the Pioneer Center for AI And it's, before that, he was associate dean and professor at Cornell. And he will tell us more about a research project within the Pioneer Center, and maybe we should tell a little bit about the Pioneer Center before that. But it's about searching for structure on falsifiable claims. So, Serge.
Great. Thank you, Johannes. Okay. All right. As Jakob said, I'm the director of the relatively new Pioneer Center. I moved here about a year ago. And that picture in the background is the building where we will be located. It's currently under renovation. It's set to open in January. I picked a representative project that we're working on. We have a number of moonshots within the center, and I picked one that I think is emblematic of the kind of approach we want to take. The moonshots that the Pioneer Center will pursue are not the same as what you'd see at DeepMind, Google, Facebook, and so on, where they have infinite compute resources and gigantic teams of engineers. We're tapping into some unique strengths that you can find in the Danish academic system and ecosystem in general. And what you'll see in this moonshot and the other ones that the center pursues is that they have a very high-touch interaction between people and machines, humanities, social science, journalism, computer science, data science, and so on. The one topic that I picked here has to do with preventing the spread of misinformation, which normally you would associate with fact-checking, and somewhat paradoxically, that isn't the goal of this research. What we're focusing on in this moonshot is unfalsifiable information. It's the things that you can't verify. It's kind of the dark matter of social media discourse. So the things that can be handled by fact-checking should be handled by fact-checking. And DIKU actually has some fantastic groups that are doing that type of work. But we're looking at a different problem. So things like, okay, so that was payback. Pseudoscience, incorrect gut feelings, all those kinds of things that circulate online. So the term that we use here is a narrative. Narratives in literature are formally defined as things involving protagonist, antagonist, transformation, journey, and so forth. That actually isn't what we're talking about here. In a social media context, we're talking about the vulgar sense of the word narrative. It's often used as an accusation. You didn't say XYZ because it doesn't fit your narrative. Oh, I had a narrative? What was it? So this is in distinction to facts. So you can have a tweet that asserts some facts, and this could be run through a fact checker, and you could probably verify that these percentages are correct. But Paul, why are you saying this? You're not saying it to get us to check those numbers. It's because you have a narrative. So what are the narratives that are advanced? They could be things like this thing of not allowing plastic straws is nonsense, it's theater. But you could imagine narratives in opposition that are saying, well, actually, your tweet left out some information about how plastic waste circulates globally, okay? So in this project, we're not talking about right or wrong. We're talking about that part that's not explicitly present in the tweet or the Facebook comment. It's the intent, the motive. It's this dark knowledge that's hidden behind the tweet. And it's important that this not just be in English. This needs to be a global thing, and it also needs to be sensitive to the culture wherever this kind of narrative processing is happening. You can see on the right, this was after a pretty big soccer victory. I experienced it myself. I couldn't get home. The streets were blocked. And there was a soccer victory, and people celebrated it, and it blocked the buses. And so here's a tweet. It's not falsifiable, but it says that if these people had been a different religion or had a different skin color, that the response of the media and the public might have been different. All right, so this is someone tweeting something. The one on the left comes very close to saying that Black Lives Matter is a hate group, but doesn't quite say it. Right, so you could parse it with modern natural language processing techniques. There's a lot of plausible deniability built into it. But as a machine learning researcher, I'd like to know, where does that piece of content situate itself in the space of narratives? If somebody shares that, I'm not talking down to the word or the letter, but what narratives is that advancing? As a computer vision person, I'm also interested in how visual signals portray narratives. Here's a billionaire celebrity couple divorce, and when it happened, all the news agencies pretty much had to run the same story, but they also had photo editors that needed to pick thumbnails to run with the story. And I can't help but notice that they picked thumbnails where the couple looks happy and functional, like everything's going to be okay. And I can assure you that not all celebrity divorces get the same treatment. In fact, right now, the narrative has changed for Bill Gates, and he isn't portrayed in this way. So some photo editor, could be a college intern, is the one that picked those pictures. What narrative were they telegraphing to the audience with those choices? There's also cases where people miscaption images. So here we have a US politician saying that a certain governmental policy is resulting in shelves being bare. But if your keen eye focuses on the currency, what do you notice? Although today it may actually be the same, but these are not dollars, right? So this photo and caption together was designed to advance a certain narrative. And when it was pointed out that that is a miscaptioned image, the narrative, at least locally, in terms of what's advanced by that image, collapses. So, and I'm going very quick because we only have 15 minutes. The work where we decided to dig into this was done by the students shown here, and it's emblematic of these cross-campus collaborations that Jakob alluded to. So we have KU, DTU, and then a former student from Cornell. And we picked this very interesting problem just to get us started. Instead of talking about Palestine and Israel or racism and things like that, I picked something that I thought would be pretty innocuous, not partisan, yet something that people had strong opinions about. So suppose you go to a public restroom, you wash your hands, and you need to dry them, and you're presented with these options. You have paper towels, you have an air dryer. So I look at this and I just think it's obvious which one is superior. I mean, who am I kidding? I know which one I'm going to pick. I'm not going to say, because it's completely, I'm not an epidemiologist, I'm not a public health expert, but I definitely have opinions about which one I would pick. And I think most people here also have opinions. But why do you have that opinion? What's it based on? Is it based on facts that you're asserting, or is it a gut feeling and then you go searching for facts to back it up? It turns out I was wrong that this was an innocuous problem. There is big money behind this, and there are smear campaigns that are launched by local distributors and rumors going up to the big companies like Dyson and paper manufacturers that they're actually putting out these bot campaigns to smear each other's methods of hand drying. So I was wrong that there's not much at stake here. But nonetheless, you can poll people and you can find out what are the narratives behind this. And they basically break down into this sort of debate of air dryers are better than paper towels or vice versa. And if you harvest large amounts of tweets that mention hand dryers or paper towels, you're also going to find some irrelevant stuff. That's the purple category. And then some surprises, like people with long hair sometimes dry their hands in their hair, which we hadn't known about. And then again, on the visual side, there are memes that express certain narratives involving hand drying. And these are mostly just fun. But it's important that we recognize this is a multimodal phenomenon. So one of the things that makes this a moonshot is it's not just one conference paper or one journal article. This touches on so many areas of computer science and all other departments at KU, among others. So, and I'm just putting that up just out of humility to show that we're really just nibbling on a corner of a very big problem. So the technique that we tapped into is something called SNAP. And we first applied this to the problem of mapping out the space of taste. And in this machine learning study, the stimuli were visual. They were images of food. And what we wanted to get at was some kind of visual map where entities would be nearby each other if you had the impression that the taste would be similar, and they'd be far apart if the taste were different. So we prepared this interface, and I'm going to skip the details, but it's basically a crowd labeling platform where you can present an anchor image and then have people click on images that they think taste more like the anchor than the other ones. And from there, you can collect a lot of so-called triplet data, and then you can train a machine learning system that tries to discover a so-called embedding. That concept embedding down here, that's something that's been around for a while. With this lower pipeline, never mind the human in the loop part, before we started doing this study, there were plenty of approaches that would do the heavy lifting of taking images, like images of food, extracting a 1,000-dimensional feature vector using deep learning techniques, and putting it into dimensionality reduction techniques to produce something like this embedding. And that would be essentially your visual menu in this case. So what we did was put in this other pathway. We have this combined cost function, where a small percentage of the stimuli are actually sent to human annotators through the interface that I just showed. And the way to think about it is that the automatically produced concept embedding, you can actually pull on it. You can exert force on that embedding and actually tell it some surprising things, like mashed potatoes and vanilla ice cream. They look very similar in photos. Wasabi and guacamole, they look very similar. But if you show the pictures to human annotators, they can pick up on the contextual cues and they know they're different. So this thing that comes out of the deep learning pipeline is not so smart after all. And so you need humans to tip it off to some of these differences. And this was also applied in the case of music genre detection. And I won't show any details, but it's exactly the same concept. You present human annotators with names of bands in groups of 3, and you ask, does this band sound more like this one or this one? And you run it through the same framework. So we did the same thing with our narratives, and in this case, the entities are tweets. And it just has to do with essentially how much the anchor person would agree with the other tweets that are presented in this small gallery. So that was how we actually got at this little hierarchy. But the kind of thing that happens, if you imagine in the future there'll be dashboards. Let's say that we succeed at this narrative-based analysis, and then something goes viral on Twitter, and you want to understand what happened. The current state of the art would be that top left one, which is completely produced through deep learning-based pre-trained system. It's called a T5 sentence transformer. And it produces this embedding, and you have these tweets that are in that space. And just skip down to the bottom right. This is the one that we're producing. So it represents a warped version of the one at the top left. And quantitatively, I won't go over these numbers here, but the point is that we can measure this in terms of triplet agreement. How often did our system actually guess the correct, in those triplets, is A more like B than C? Does our human influence system do better? And numbers that are bigger here mean that it did better. So SNAC T5 is our approach. So the kind of thing you could do in this dashboard if you wanted to understand narratives is you just harvest a whole bunch of tweets, run it through the narrative-based embedding, produce this visualization where you can mouse over these dots, and each one corresponds to a tweet or a Facebook comment. And so you can look at these and say, oh, this one has to do with paper running out all the time, or this one has to do with COVID spreading from air dryers. So this kind of thing quantitatively got better when we had that human in the loop representation. So this is just the beginning of a moonshot. It was probably a 10-year kind of project. But as I said it in the title, this is about searching for structure in unfalsifiable claims. Generally, everything we're looking at is actually what's discarded at the very first step if you're doing fact-checking. And we're actually taking the opposite. We want to look at how that space is structured. So I'm going to wrap up there. I'm just going to leave the key questions up here, and then maybe have time for one question. And thank you for your attention.
Thank you very much. Can you hear me? we have time for a question. Yeah, I have one question. If someone wants to contribute or be part of it or learn more about this, what should they do? How could they interact with the Pioneer Center?
Yeah, so I would say we have this QR code that goes directly to this paper, and then we have a Twitter account and also LinkedIn, so you can follow us there. There's the Twitter account, and you can also just email me directly.
Yes, thank you very much, Serge. Really, really interesting. So, next speaker is Boris Düdder, who joined DIKU in 2017. He came from the Technical University of Dortmund and worked in many different areas, but some of them are software engineering, fintech, security, and privacy, as well as formal methods. Boris, stage yours.
Yeah. I will not talk so much about moonshots, essentially. So my question, when I was invited, was challenging, essentially, because one of the questions was, can you say something about sustainability? So since I work in formal methods, usually proofs are not so much related to sustainability. But so I took the liberty, essentially, to briefly think about why do we do what we are doing, essentially? Now, can I frame it in terms of sustainability? So one of the questions that we very often have is essentially our systems get applied. We have usually from scientific curiosity another motivation to pursue certain topics, of course, but very often we forget what is essentially the impact on society for that. And I will talk about part of our work that I do with our group. Essentially, one of the questions that we have when we work with systems is, what is the effect, essentially? Also, I can propose a lot of improvements, of course. Some are minuscule. Others have bigger impacts, essentially. But how do I find out what is the impact, essentially? So essentially, I took the liberty in this talk to look a little bit more what is the impact of formal methods, and in particular on security. So security changes over time. No? When we talk about software security, hardware security, current trend is, of course, we see upcoming, hopefully somewhere in future, quantum computers that can attack current encryption schemes, essentially. So mid-90s, Peter Shaw found an algorithm that if you tweak it a little bit or rephrase the problem a little bit differently, can essentially factorize big numbers, essentially, using quantum computers. So which means essentially every algorithm that uses factorization is attackable via Shaw's algorithm. So which led to a lot of hectic work, in particular when the first commercial quantum computers showed up. It will take time, of course, but from security perspective, it is a big pressure that was exceeded on our environment, essentially. So that is the pressure that's building up. Either we evade or we build up resistance. From security, we rarely evade, so we need to build up resistance. So how did we do that? So essentially, one of the visible parts is, of course, how does it affect commercial systems? And you have probably seen also last week the official decree about how commercial systems should be built in the US that are quantum computer resistant. There is now a suite of different algorithms doing that. It's a good news. Bad news, some of them have been already attacked and cracked, so which is still an ongoing problem. So it is a rather strange process right now that we have not seen in the years before. But the important part, I would say, is definitely software and firmware. So software that is running either enabling hardware to provide services or on a level of applications get signed. So building trust essentially on the platform that we have. So we have seen a lot of approaches right now over the years, from trustworthy computing, for example. Microsoft was pushing that for the TKM platform, for example. You cannot build secure systems based solely on software. So you need the whole stack essentially, from hardware that is trustworthy, and then you can build security on top of that. Because now the weakest link in the chain breaks all, and we have seen that over multiple years. We have seen that with TEs. Yes, of course, Intel is out of the business of TEs because they got broken so often, it didn't make any sense to invest in that anymore. So the hope is essentially going in this direction of different algorithms. So I will spare you all the details of these algorithms. But the idea behind that is essentially to make security, and here encryption in particular, future-proof. Good. Now, coming back to the topic of sustainability, I was thinking a little bit, we are computer scientists. We have learned computer science is a science of trade-offs, essentially. No? So there is no free lunch. No? So we always have to pay our bill, essentially. So how do we pay, essentially, the bill now for these new algorithms that are more expensive, of course, in computation? But I was more interested in how expensive are they with respect to environmental impact via energy, essentially. And it turned out it is essentially not that easy. So let's look a little bit where our computers usually run. Data centers. No? So everybody is using smartphones, tablets, and so on, but most of the computation is not local run. It's essentially data centers. So the projection is in 2025, every 18 seconds, a user, or all we, will interact with data centers, essentially. So which means they are responsible for data, computation, and all the stuff around that. So, which means also we put a lot of these energy consumption from devices that we usually carry around, no? We usually have low power devices, to these compute centers. Right now we have 7.2 million data centers. No? Biggest fraction is run in the US with 2,670. And in particular, we see also the pressure now through regulation is it needs to be neutral with respect to climate. If you live in the US for quite a while, that was already law in California, so you could for many years not replace data centers if you were using more energy than the ones that you were replacing. One big problem with data centers is you have to tear them down. So essentially you cannot upgrade data centers. No? So they are throwaway technology. The important part is also where is the cost essentially. It changed very much from infrastructure, producing a lot of heat usually, to really the server part. No? So that is an important trend that we see, and it's also ongoing. The biggest centers right now consume around 100 megawatt, and which means that is roughly 80,000 households. So it is really not that little. When we look into what is happening there, so cloud computers are still there, they will be there, of course. Traditional ones are dying off, essentially, at least in this trend, but hyperscale architectures are growing, essentially. So the computational demand, in particular of interconnected devices, is growing. So essentially, that is what we are seeing, and one of the predictions, at least, is that the energy consumptions of all data centers right now 2% grows up to 15% in the next years. No? So the estimate is 2035, which means everything that we do there has a very big lever. No? So every computation that we can spare and make more efficient has really an impact. Good. I promised to talk a little bit about cryptographic protocols, essentially security, which is interesting because there is not so much data material around how much energy they really consume. So I went a little bit through the studies and tried to aggregate some of the data there. So you see typical protocols, for example, Kerberos, that is usually used for key distribution, but also for tickets, so that you have built single sign-on services. The other one is essentially an elliptic curve Diffie-Hellman, also for key exchange. So I chose two of the more expensive ones, but they are used everywhere. So every time you connect to a data center through a secure connection, essentially, these algorithms are executed, essentially. No? Technically then used to switch to a much cheaper security or encryption method, but how much do they cost? So essentially, if you use here the computation in millijoule, no, that is the, let me see, can I, it's there's not a, here, no? Then for Kerberos, you use less than a tenth of a millijoule, which sounds innocent essentially. But if you, for example, use that with elliptic curve cryptography, then you already up to 50 millijoule. So let's see a little bit when we now connect that to networks, because these protocols do exchange messages and multiple messages. So if we add also the perspective of message transfer, then we see Kerberos, even though computation is not so expensive, it is at least communication intensive. The cost is rather high. So, which means when you calculate that, then you're around 50 to 85 millijoule per invocation essentially, and also communication. And then looking up, when we use 100,000 calls, which is not much for a typical data center, then that sums up. And if you then look what that costed, I took the 2019 numbers because they were innocent. I know the current cost of energy is thrilling to a lot of people, so I took the old ones. Then for 100,000 we pay 0.1 krona and or 0.2 for krona per 100,000. But usually we talk about around about 10 million per hour for such a compute center. So you can understand a little bit, it has a big impact what you're doing. I took the liberty of using Wi-Fi here as an upper bound, so there are of course cheaper interconnects, but usually there is a Wi-Fi somewhere in between. And of course, that also grows about the number of hops that you do. So how direct is your connection to your compute center essentially? So if it's a local one, then of course you have usually two hops at least. If you have a longer one, then you run of course in multiple hops, and that grows also in price. So you see there, 2 minutes? Good. So you see there definitely the distance is important, so having local data centers makes a lot of sense, but also what you are doing. What is the cryptographic schemes that you are employing there? So what we are doing for a lot of projects is essentially we look into how can we make that efficient, now without compromising the security properties of algorithms. As an extreme, usually I love to use blockchain because it's a very radical approach, zero trust environment. I don't trust anybody essentially. It has high costs, so which means it comes with a high price tag, and there is something that we can improve on. So which means when we look into high consistency, high integrity computational environments plus zero trust, then we end up with an enormous energy amount usually. We see switches to proof of stake, to other algorithms, and that they of course lower the cost, but essentially most of the cost really comes from the theoretical boundaries that we get from high consistency and zero trust requirements for such algorithms. And very often we go, in particular also with the students that are part here and sitting here, we are looking into the question, what happens if I now also add confidentiality and privacy to that? So if not everything is transparent, so not everybody is allowed to see the information that is stored there. So transparency is nice for auditability and so on, but if that is your IP, no, so your intellectual property, you are very hesitant to let everybody know that. So there we look, for example, in very efficient schemes for zero knowledge proofs. So where you prove a statement, but you don't leak any information about the statement, essentially. I'm on it. So that's also my last slide, so I get the point.
The only speaker today is who's not from DIKU, from the outside. And Jakob mentioned in the introduction of me that I worked in the IT Industry Association, and back in my student days, and in those days, Specialisterne, where Carsten is from, won the IT prize. And the IT prize is not kind of like a small prize; it's a big prize. It's actually a big stone formed as a chair. So I was a student who got the honor to carry this very big stone out in the car of the founder of Specialisterne, Torben Son. So I hope you get mic up, Carsten.
I'm trying not to. Is it on?
Yeah. Yes, and you are the CEO of Specialisterne, and before that you worked in Nordlys, Future Culture Denmark, and a number of other areas, and I hope you give us a good introduction to Specialisterne. Thank you for coming.
Thank you very much for inviting me, and thank you much for showing up. And I would say now to something completely different. And then again, maybe not, because I mean the last topic was, I guess, partly about sustainability, and the area that we are dealing in and working in is really all about creating a sustainable labor market. So first of all, I have to tell you guys that this is really a trip down memory lane for me. Back in the late 80s, I spent way too many Friday mornings in this room, or in this building, having had way too little sleep, trying to understand or comprehend the beauty of microeconomics. So my ambition for today is that this talk is going to make more sense to you than microeconomics did to me. Maybe I haven't set the standard too high, but still. I am the general manager of Specialisterne, and as Anna said, Specialisterne was founded back in the early 2000s by Thorkild Sonne. He had a son who got diagnosed with autism, and really it was obvious to Thorkild that his son had some really rare talents, but also very clear that he had some severe setbacks and some difficulties, especially in the social field, his capability to cooperate with his fellow mates. He was only a small child at the time. So Thorkild founded Specialisterne on the fear of, or the question he asked himself was, will there ever be a job for my son? I mean, are we capable of creating a labor market that can comprehend and include people with rare skills and some obvious deficits that need to be attended to? So on that basis, he started Specialisterne, quit his day job, and immediately hired 10 autistic persons, and the day after sold them to TDC, which was our first client, and still is the biggest client that we've had ever since. So really is so the aim of Specialisterne today is to really to create a more diverse labor market that should create the job opportunities for every talent and for every skill. So really trying to curb the labor market divide as it is today. I mean, it's really also very, very silly because there is so much talent out there, and everyone should have a chance to participate. And we need each one of you out there. So that's what we do. very briefly, specialister in Denmark, we have like two main focus areas. One is education. We have an education program for young adults, people from 17 to 25, who, due to their autism diagnosis, fail to be able to participate in regular school systems. So basically, this is a maturity project. It is a 3-year program providing young autistic talent with life skills that should hopefully enable them to enter some kind of education or some kind of meaningful job. So that's one part, and we are also running an academy, specialist academy, which I will tell you a little bit about in a short while. And the target group there is actually really people with either master's or bachelor's degree in the STEM area that also needs a little bit of help. I'll get back to that. The other thing we're doing is like specialist in the traditional, you could say. Like we currently have 30 consultants who all have Asperger's or ASD, autism spectrum disorder for short. They're all employed by us, and they're all working for Danish companies in various areas. Get back to that also. Currently, this spring we onboarded 11 consultants in Den Danske Bank alone. So they have overtaken TDC as our largest client right now. We're also doing recruiting programs for companies. Some of you might have seen the program series on DR, The Hidden Talents, where you might have met Louise from Novo Nordic, who obviously has some rare talents, but also was suffering in other areas that, like, well, basically we say that autistic persons, they have a different comfort zone than the neurotypicals. It's not necessarily smaller, it's just different. And some of the things that keep the autistic person in his or her comfort zone is totally freaking for me. So it's just different, basically. So the whole idea is to keep everyone in their comfort zone. And we are also doing neurodiversity management programs. I'll be talking mainly about the academy and the consulting bit for the rest of this session. I brought 20 slides. I have 20 minutes. I really have to finish in 15 in order to make room for questions. So I better speed up now. Anyway, just to let you know that everything was invented here in Denmark, in Belongie. But now we are a global company. We have offices in 13 countries. Just the last one we opened was in Bangalore, or it's Bangalore over here. Basically all started up, somebody wanted to say, hey, I want to take this idea to some new countries, and we have done opened a lot of new countries together with SAP, whom we've been recruiting for many years. So we are a global organization. We don't have any office in Africa due to the lack of market maturity, basically. I mean, the conditions for autistic or neurodivergent talent differs from country to country. It's become a lot easier to be neurodivergent in Europe, and especially in Denmark. But for instance, in India, I mean, it's so stigmatized, so people don't go flagging, I'm autistic or I have an autistic child, because there are so many downsides to that. So it's a long and tiresome journey, but we will get there eventually. We have done recruiting in China. China suffers a little bit from the same thing. Basically, it is kind of, there's a lot of stigma related to autism still. And even if you just have to go to France. In France, the psychologists believe that autism is due to bad motherhood, basically. And even renowned psychologists claim that. So the mother did a poor job upbringing for the first couple of years, and that's how you get autism. So we have a long way to go. This is just to show that we have done a lot of business for a lot of companies. I'll skip that. So neurodiversity. What is neurodiversity? I mean, neurodiversity is a fact of life. It's nothing we can discuss. It's basically acknowledging the fact that all brains think differently. No two brains think the same. If all brains were thinking the same, we would probably have been extinct alongside with the dinosaurs. So diversity and neurodiversity is the prerequisite for developing our society. And I would bet you guys that none of the major breakthroughs for the last 100, 150 years has been made by a person who was not on the spectrum somehow. I think it's probably 89% true, because the rare skill to be able to really deep dive into a very, very specific area without caring whether other people like you or not. You are here for the sake of the matter. That is kind of autistic. And I would say that most neurotypicals fail to have that capacity, the ability to go on to be that persistent. It's what we call an autistic feature, anyhow. So we'd like to think of neurodiversity as a different thinking, basically, and acknowledging the fact that in order to lead everyone the same, you should treat them differently. And once you have understood that, it's much more easier to be around in the world. It should trigger your curiosity instead of your fear and your anxiety. Just think as the other person as people who might be thinking slightly different from yourselves. So figuring that out is what this is really all about. The thing is with the neurodivergent, that is basically the 15 to 20% of the population who is not in the middle of the normal distribution. So we would consider the neurotypicals. The rest might be neurodivergent. And what normally goes for neurodivergent persons is that they tend to have some really rare, like distinct peaks in their skill sets, but also quite often some dips. So the idea of having an inclusive, diverse labor market is to create strategies where you get the full benefit of the peaks and try to offset as many of the dips as possible. Easy peasy. Not. But I like to try and simplify things a little bit, because otherwise we will get nowhere here in life. So when we talk about the autism advances, it's normally known for like their independent thinking, their excellent math and computer skills, great orientation to details, and very high level of perseverance. Those are the skill sets that we normally say this is the autism advantage. And it's known that 1/3 of the population has autistic features, and around 2% of the population is believed to be truly autistic. That means that they will get a diagnosis if they ask for it, which is really not that relevant in my world. But just acknowledging the fact that it's quite a few of us. And some of the researches that we made for Harvard Business Review found out that autistic person were 60% faster than their neurotypical peers. We recruited 250 persons for JP Morgan in New York, and they did a similar survey and came to the same conclusion. So it's really a matter of trying to exploit the benefits of onboarding autistic persons, or neurodivergent persons for that matter. So we're talking a lot more than 100 million people worldwide. So just covering the autistic, if you include people with the ADHD, you could triple that amount. If you include people with dyslexia, which is also considered a neurodivergent feature, you can triple it again. What people with dyslexia have in common with people with ADHD is that they are quite often being quite extrovert, being quite creative, but can be lacking their ability to concentrate for a long time. So really the ADHD people or the dyslexic people also need a more like a closer management style, like breaking big tasks into smaller bits in order to get the full benefit of the task. And the weird thing is that even though most autistic persons are quite well educated and their IQ is considerably above normal, 85% are either unemployed or underemployed. Specialisterne, we get people with PhDs in mathematics, and they are delivering pizzas or delivering in newspapers, just because of the fact that they were not fitting into the traditional recruiting model. So the thing is, and what is wrong with the traditional recruiting model? It's basically that the way we recruit people today is by cover letters and doing interviews, and basically what you test is people's ability to write a cover letter and do a job interview. A traditional interview is every autistic person's worst nightmare, because you cannot prepare as well as you would like to. You don't know who you're going to meet. You don't know where you're going to meet. So basically, they would normally do a fairly poor job, even because they know that this is not their comfort zone. And then when they meet their hiring manager, they would be asked questions like, "Where do you see yourself 5 years from now?" Basically, nowhere. And they were like, "Do you thrive in an environment in constant change? Do you like to be juggling with many balls at the same time, or are you really a team player?" They would say, "No." And basically, everybody would say no if they dared to, but then you would never get the job if you said, "No, I hate juggling with many balls. Please give me one ball at a time." We know, with Lionel Messi, right? You say, "Oh, you need to juggle with at least 3 balls here." You would never become the world's best football player. So this is what I call a traditional HR bullshit. And this is the main reason why autistic persons do not get a job. So what we do, we don't work with cover letters. We don't work we work with tests. And that's basically the only way to, instead of asking abstract questions, you get really abstract answers. Neurotypicals, we tend to improvise, elaborate. Okay, this is a weird question. He's probably want me to answer something like, "Where do I see myself job-wise 5 years later?" But if you really take the question literally, it does not make sense, and you could get any kind of answer. So what we say is basically, if you want to get the full benefit of autistic persons, you should stop focusing on the job profile and focus a lot more on the exact task you need solved, and that is what we do. Right now, these numbers have not been updated for a couple of months, but I think it's probably still quite true. There is a huge lack of a shortage in the labor market right now, and people are really screaming for candidates within the STEM areas. And at the same time, I would say that at least 2,000 to 3,000 persons could easily go in and fill in STEM roles in Denmark if we give them the chance. They're sitting at home in their basements playing World of Warcraft. Their moms and dads know they have the skills. Nobody else knows. So that's why we created the academy. What we do in the academy is we take people who have a bachelor's degree or a master's degree or have shown interest and skills in IT but do not have a job. This is a crazy situation, but this is due to what we just talked about before. We don't ask a diagnosis. We just ask, do you find it difficult to either get a job or keep a job? Do you not understand what your boss is telling you, or are you struggling to understand what your colleagues are telling you? I have to speed up. If you can recognize yourself in one of those criteria, then we can help you. And then instead of writing cover letters, we do upskilling. We test on a pattern recognition. We test on all kinds of metrics to find out what are you really good at. We have a great collaboration with Microsoft. We also have a great collaboration with IBM on the SkillsBuild platform. So basically we test, and then we start working with cases to make sure that we know exactly what people are good at. And then we also ask the questions that most employees do not ask. I mean, are you sensitive to smells? Are you sensitive to noise? Some of those things that can actually be relevant in a recruiting situation, but that most people refrain from asking. And so far, 75% of all the candidates that we have run through our academy who were unemployed at the moment when they came to us, we have placed them in proper jobs, and not just flex jobs. We had sort of like high-paid full-time jobs. 11 of them in Danske Bank just this year. We are talking Netcompany. We are talking about Ørsted. A lot of companies. So just the numbers. About almost soon 50 candidates have been through the academy, and 75% of them have actually gotten a job within the tech, data management, processing, quality assurance. Those like regular, ordinary STEM areas. Mainly in the private sector, we are really struggling to get a foothold in the public sector, which is queer, which is really weird. Okay, the last bit is also, obviously, I spend a lot of time talking to companies, because, I mean, without the willingness of the companies, we get nowhere. So here we get, you get the inclusion by having the willingness to onboard or hire people who are different, but now that's where that gives you the diversity, but the inclusion bit is knowing how to manage well and doing well in your management. So that is also something we do. We work intensely with companies, telling them about good governance in management, and telling their colleagues what is it like to have neurodivergent colleagues. And they normally always find out that a few of their other colleagues are also actually neurodivergent. So and this is just some of the effects that the companies where we have actually managed working with neurodiversity, bringing in other types of colleagues, they say that the team atmosphere went up, that internal communication rose by 40%. Motivations and performance went up by 40%. Just acknowledging the fact that in order to lead everyone differently, you should treat them, lead everyone the same, you should treat them differently. That was it for me. And Dr. Serge, that... Right.
With time for one small question. Tom?
So, since we represent universities, I wonder if you have any suggestions of how to make our education more suitable for neurodivergent people without making it less suitable for neuronormal people.
I mean, all research shows that the good practice that works for neurodivergent persons is actually working quite well for most other people. Basically, it's about cutting down on irony and sarcasm. That's a good place to start. And trying to really be clear in your communication. You should crash test all your internal communication on an autistic person. If it makes sense to the autistic persons, it makes sense to everyone. That's what I'm saying. But we are having a dialogue about these matters. I would very much like to go into a more detailed dialogue on how to do that.
Yes, thank you. One last question. Yeah.
I'll be here for the reception also. Please, if you are a student, want to know more about the academy, or if you are running a company, would like to know more about how to onboard autistic talent, please, or if you have colleagues, whatever, I'm here for you.
Thank you very much, Carsten. It's good to see you networking and talking and finding old friends. We have two really interesting talks for you, last two talks of the day, from our human-centered computing section. Both of the speakers arrived to DIKU last year, 2021. The first one is Barry Brown. He's a professor in the section and researching in the use of digital technology and design of leisure technologies. Professor Brown previously worked as the research director of the Mobile Life Research Center until 2017, and as an associate professor in the Department of Communication at the University of California. Barry, I'm looking very much to learn more about the halting problem when self-driving cars stop in traffic.
Hello, thank you for that. So I get to talk today about one of my favourite subjects, which is driving. So I've been studying driving and what we do with roads for maybe like 20 years now, actually. And back when I started looking at it, there wasn't much computer science in cars. Maybe you had one of these, do you remember these TomTom units that you plug into the cigarette lighter socket, or maybe there's a kind of engine management system. But nowadays, our cars are, well, they're basically smartphones on wheels, aren't they? They've got these big screens, and along with that, there's this exciting possibility that we might have self-driving cars soon. And I'm particularly interested in this because I am a completely abysmal driver. And this is my main interest in driving is, can I invent technologies that will stop me killing people on the road or potentially killing myself? But unfortunately, the whole self-driving car thing is actually kind of, it's got stuck in a jam, as the economists put it. And actually, someone like Chris Urmson, so he actually founded Google's self-driving car division, really gifted computer scientist. He used to talk about how his young son wouldn't need a driving license, and now he talks about it being sort of 30 to 50 years away. Not so good for Google, but great for researchers like us. It means we've got a career ahead of us here. If that's not worrying enough, there's also this kind of, you might have seen some of the media reports or heard of the incidents where self-driving cars have caused trouble and even caused fatalities in traffic. And these cars are being tested mainly in the US and China, but they're being tested on our roads quite widely. So this is potentially a cause for some concern. Now, as somebody who studies kind of road interaction, I've been kind of tracking a little bit these kind of advent of these self-driving cars in different ways, and I was kind of a little bit sort of sad one day because I kind of realized that a lot of the data on how these cars are doing is locked up in these car companies. It's locked up in companies like Waymo or Cruise. And although I have friends in these companies that were like, we're not going to give you your data. It's our data. We're not going to let you look at these kind of things. And I was sort of scrolling through YouTube videos of these self-driving cars being kind of driven, and I thought, could I actually use data from YouTube? Because it turns out there's like thousands of videos of these cars interacting in traffic. And so this year I've been trying to kind of see if I can kind of do a systematic approach to this kind of data, and although it's obviously kind of quite wild data, quite uncontrolled, it does give us this little chance to look at what's going on with self-driving cars, out with what companies like Cruise or Waymo or Tesla would give us access to. So I'm going to talk a little bit today about this kind of first little kind of attempt that we've done. Now, usually I go out and video things myself to study them. That's my speciality, and I should say that I'm working with Nissan on their self-driving car, which unfortunately isn't very good. But the data I'm going to talk about today, I've actually got from YouTube. It's kind of quite an unusual place to get your data, but I think you'll see that even though data is a bit wild, we can really get some interesting stuff about how self-driving cars are driving on the road. So I'm going to use two main sources. One from this chap called J.J. Ricks, a really nice guy who's recorded 70 or so recordings of him driving with the Waymo car. And then I'm also going to look a little bit at the Tesla full self-driving, which is, if you're a bit of a driving geek, you might have already heard about that. I'm just going to jump in. I'm just going to drop you in, and I'm going to start by playing a video of the Waymo car from J.J. Ricks. Now this car has been tested in a suburb of Phoenix called Chandler, and you can see basically the setup there. There's no driver, which is kind of quite interesting. JJ's in the back here, and he has multiple cameras to video different things that are going on. This is the sort of visualization you get inside the car, and this is kind of the sort of videos you get. It's quite quiet suburb, quite good for testing self-driving cars, and you get this kind of data. Much of it's kind of boring. It's driving around like this, kind of seems to be tracking the road quite well. But in this clip, things go a bit wrong. What actually happens is that, I don't know if you can see on this visualization here, there's like traffic cones here. And the car just kind of gets stuck. It halts.
Oh, so now I'm going to turn right when the right lane is closed off. What is the planners still wants to go in this lane.
So, and that's what happens is get stuck and cars start to pull up behind. You can see them in the mirror there and start driving round the car. Now, automatically, the car works out something's wrong, calls driver's assistance.
Alright, support. Hey, I see there's some funky stuff going on here. Yeah.
So the car's stuck. Roadside assistance is coming. JJ's kind of okay, so just waiting there. Cars start to kind of drive around and get a bit more aggressive around the car. It's coming. Roadside assistance is coming. But then it gets even worse.
It's, okay. There we go.
Car actually looks like it is on its way.
I don't think it was supposed to do that. Oh no.
Actually, did it pause again? It looks like it did.
Oh, now it's blocking the entire road.
And it just stops there, and the police come, construction workers come, eventually roadside assistance comes. At that point, the car decides that it's going to make a getaway, and the roadside assistance guy has to chase after the car to get hold of it. And this is kind of what I'm interested in. I'm interested in this kind of thing where these self-driving cars are halting on the road at inappropriate points. And I would actually say that this is actually one of the biggest kind of problems that they have, for various reasons, they stop in a safety critical way, and that causes these kind of problems. And I contrast this with how humans stop on the road, because we don't just stop, we yield to each others. And one of my kind of big kind of questions is, can we teach self-driving cars to yield? Now, turns out sort of sociologists of the road, there are such a thing, would you believe it? They've been studying how we interact on the road for years, and this is some kind of work that's been looking a little bit at how, you'll know this when you're driving in Copenhagen and you've got cyclists, who's going to go first, the car or the cyclist, or in this case, the pedestrian or the van. And you can see that we have this little thing where we kind of nudge and we move in little ways. You see the pedestrians going over to the left of the crosswalk there, showing that they see the van, but that they're going to go first. They're not going to yield for the van. Now, as I say, self-driving cars need to yield like humans, but they can't quite. Let me play you another clip. So this is the Waymo again, by the way. You can sort of see a little bit. I usually make these little comic strips. It helps you understand what's going on. You can see that the car kind of stops there, and that this dad, I presume, kind of waves the car on like this, yielding for the Waymo car.
Sorry, self-driving car. It sees you, so no worries about that.
So the driving here is perfectly safe, right? It's not dangerous, but remember, accidents come from the accumulation of small errors in driving. And what's going on here is basically the car, like the family are yielding for the car, but it just sits there. And then eventually JJ has to say, sorry, self-driving car. And it takes it 30 seconds to do this pretty basic kind of road interaction. And in fact, actually, it's worse than that. If you kind of look at this closely, you'll see that the mum actually starts to cross the road with her kids, and just at that point, the Waymo car starts to move again. So she stops and gets back onto the pavement there. This is kind of like a basic unit of road interaction, yielding, and actually more complicated forms of road interaction kind of use this as a kind of building block. And one of them is like what we call like a kind of four-way stop. If you've ever driven in the US, you'll know they don't have so many roundabouts. They have these four-way stops. And this is a different system. This is the Tesla FSD system. We're going to look a little bit at how it tries to get through this intersection. This time it's cars, it's not pedestrians. I've got a little counter up there, and that's how many cars go ahead of the Tesla when it should have went. So not the most impressive performance by, the company owned by the richest man in the world. But anyway, I don't want to be unfair. I mean, I think these technologies do amazing things, and they have done amazing stuff. But clearly they're still struggling with a little bit of this kind of social interaction on the road. And the problem here isn't just that the Tesla doesn't know to go when someone's yielding for it, or vice versa. But if you actually kind of look at kind of in detail at how we drive, you'll notice that often we have these little kind of subtle interactions where we're both kind of moving at the same time, but we see who's slightly ahead of and who can make the claim to actually go. And you have to look at kind of, these things kind of slowed down to see why is, for example, this black car here, the fourth car, goes ahead of the Tesla, even though it actually slows down and waits for the Tesla. But the Tesla just doesn't take its chance and doesn't move. So this is kind of the thing I'm kind of looking at. I'm looking at halting when these self-driving cars stop in traffic, and I'm trying to contrast that with how we as human drivers or pedestrians or cyclists, how we stop in traffic. And I've got kind of two things I want to kind of pull out of this. First one, I'm kind of interested in how we can design self-driving cars. That's obviously kind of one kind of important thing. Can they understand these social interactions? But I'm also worried about this. When half or a third of cars on the road are self-driving, and they're driving this way, who's going to have to deal with that? Who's going to have to pay the cost of self-driving cars? It's not going to be the people who can afford those cars. It's going to be pedestrians and other road users. Thank you.
Thank you very much. Good to see you. I think we have time for one question.
You said that they start halting just in the middle of the road, right? The cars.
But sometimes not. Like obviously some of them.
What if we lack of sensors? Because I know that Tesla famously rid of their radar sensor because it was too expensive, and they crashed with 3 or 4 motorcycles fatally because they didn't recognize it. Because now they only rely on computer vision and paradoxes to calculate distance. So might there be a sensor issue, or is it like this?
Yeah, it's like driving's one of those things when you start picking up the onion layers. It's so difficult, and even actually just seeing where other cars are on the road is a kind of big problem. But I think that the thing that I've been kind of looking at is so most of the collisions these cars get into are when cars go into the back of them because they get impatient. So like why are you not moving? And then they think they're moving, and then they go into the back of them. So actually, I think like at least the Waymo's got these kind of this LiDAR systems. It's actually pretty good at seeing what's around. I think you're right about the Tesla, though. It still struggles a little bit with seeing fleshy bodies on the road.
Thank you. Thanks. Thank you very much. Next speaker, Valkyrie, Serge. Welcome to DIKU. You joined us last year. And you graduated with a PhD from Berkeley University. And you worked in different areas such as innovation, teaching, developing devices within virtual reality, UX, and so forth. And today you're gonna tell us about 3D printing ideas from the 1960s. I'm looking forward to it.
Yes, I am. Is this on? Yes. Perfect. So today we're going to talk about how we can 3D print stuff that thinks. This stuff doesn't use electronics, it just uses air and very special tubes. So, my research goal in general is that I want to be able to sense input that people do with physical devices. These are the kinds of devices that I have in mind. So there's tons of research in HCI, HCI being human-computer interaction, about why we like to use physical devices, why we like to use different kinds of physical devices for everything we do, why it's not that satisfying to use our smartphone for everything, and instead, we want to use a wheel when we drive a car. As Barry, I'm sure, can say. Or why we want to use a dance pad when playing a dancing game. But designing these kinds of devices is really difficult. So here on the left, you can see this is from Microsoft when they were working on their Xbox controller. Basically, there's 3D printing involved, but it ends up that you usually 3D print a case, and then you smash a whole bunch of electronics inside the case. So that means that there's a lot of manual work where you have to solder all these things up, you have to program them, et cetera, et cetera. This problem is even worse if you have to change the design of the device, because then you have to undo all of the work that you did, print a new shell and do it again. Or when the device reaches the end of its life, you have to separate all of the plastic parts from all of the electronic parts and recycle them separately. So to help with some of these problems, we went way back to this work from the 1960s. This technology is called fluerics, and it's basically, it relies on jets of air interacting to do computation. So people came up with this idea in the 60s when they were freaked out about the Cold War, and they were like, what are we going to do if our computers get exposed to radiation? You know, the traditional electronics won't like that. What if we have to put our computers in wet environments? What if we have to put our computers in space? You know, there's all of these situations where regular electronics really don't like them. So I also have one of these devices, which you're welcome to come ask me to look at later. But basically, they make very precise channels to direct air. So if we can make these precise channels to direct air, then we have this actually very appealing medium. So this is a totally passive medium that we can produce shape and function together on a 3D printer. So the bunny that you see in the picture and on the desk here, this has those special tubes inside to do computation, and I made it on the same machine as I made the outside shape of the bunny. So I can't do that with the traditional electronics that I showed you, right? I don't have to sandwich the case over anything. I just print it all as one big piece. It's capable of doing sensing, processing, and output, which I will talk about in a second. And things that use this air-powered computing don't have state. So there's some mechanical computers, I've seen, computers made out of dominoes or whatever, and even though you can make those all on the same machine, after you compute with the dominoes, you've got to set all the dominoes back up. So how does it work? Here's an example of an air logic transit. So we call them transits instead of circuits because the air only goes through one way and comes out the other end. This transit can sense input with touch. It can perform computation. Here we're just doing an OR, and we can create output all with air. So this is what that same transit looks like, all twisted up and put inside a bunny. And here is that bunny in action. So we've got the tube with the air coming in. When we pet the bunny in these two touch holes, we can see that the bunny's tail wags. So when we put the air through this, what's actually going on? If we don't interact with these touch inputs, the air just flows straight out the top. So that would be the bunny's head. But if we cover that air input, then the air instead stays inside the device and it goes towards this, which was our computation block. So with this particular computation block, it continues straight through and it comes to our output widget, which is this wiggler, which oscillates as you saw, and then the air goes out. So now we have this nice little truth table for our bunny. Are we covering one widget or the other widget? If so, then we wag the tail. But of course, we can do more with this than just make one bunny. So we developed a whole collection of input, output, and computation widgets to sort of prove the point of what we can do. So let's talk about input really briefly. Some of these are adapted from existing work in HCI, but in any case, we've got touch, we've got button presses, we've got sliders and dials. So the general idea, as in this touch widget, is that in order to compute with the air, we just have to keep the air inside. So here, if we don't touch it, air goes out. If we do touch it, air stays in. We can then put sort of shells on that. So for the button here, we now have a tactile thing that when we press it, it holds the air in. We can have stateful switches that don't pop off as soon as we release them. So the rocker switch lets us set true, false sort of more permanently. And we can combine them into multiple inputs into a single sort of track. So this is a slider, and basically the way the slider works is a series of touch widgets, so only one can be true at a time. We slide this sort of controller along the top, and whichever one we're covering is the one that's true. The dial is essentially the same as the slider, but sort of like a rotary version. But the thing that's really interesting here is the logic. So, of course, the logic widgets are going to perform logic based on their inputs. And this is based on the principle of jet interaction. So when a jet is moving straight through the air, it'll just continue going in the direction that it started, unless it's hit by another jet, in which case it will get deflected by that jet, according to the energy and the direction of that jet. So we can use this for our calculation. So we've got the free jet. In this case, if we send it through, this is our AND gate. If we send the free jet through our AND gate, it continues straight. So you can see here, we blow through here, and the air comes out there. The same thing happens if you flip it around and do it on the other side. But if we send both jets through at the same time and they have mirrored angles and the same force, then instead of going through one or the other exit tunnel, they'll come straight out the central tunnel. So suddenly we have this functional AND gate where the presence of one input or the other leads to different outcomes, but the presence of both inputs at the same time leads to something else. So basically, we started with, this is what the historical sort of AND gate looks like. This is the size of the tubes that they were working with. We had to make them somewhat bigger to make them work on our 3D printer, but essentially all of the structures are still the same. So we still have oh sorry, that's a really pixely picture. So we still have sort of a reduction, and we have an area where they go, we have a reduction to make the air into a jet just before it interacts with the other jet of air. And then they have an interaction area where we do this computation. So back to all of the gates, we talked about AND. We can also do OR, which I showed you in the bunny. Essentially, this works on the principle that the air wants to stick to the sides. So if we send it through here, it'll sort of sweep through and come out the end. And similarly, when we have two, we can push straight through. Our XOR gate is very similar to our AND gate, except that we turn the single outputs into one output channel, and then we send the output, this comes vertically out of the screen, this escape valve here. NOT requires something slightly different. It's the same geometry, but in this case we actually have a power channel. So we send air through P all the time, and if P is coming out where we would expect, then we know that A isn't on, because if we've turned A on, suddenly we've got P being redirected. As the final part of the chain, of course we have to make the information useful to the user, otherwise they have no idea what's going on with this computation. So we looked at visual, haptic, and audio outputs. So for our visual output, we have a pin popper, which pops up when it is activated so that you can see the result of your calculation. We've got a whistle. Basically, this we can tune this so that we can hear, what the result of our computation is. Nope sound. Okay. The oscillator is sort of similar to the pin popper, but instead of going up and staying there, we can actually set the air so that it wiggles in place as the part falls out of sync with the airflow. We've also got a vibration motor. This is essentially the same thing that's inside your cell phone. We just blow a wheel really fast and it makes it shake. To make it easy to experiment with this stuff, we actually put together a GitHub repository that has a plugin for Autodesk Fusion 360, which is a popular program that we use for making stuff like this. Essentially, there's two ways that you can design with the widgets. So we built encapsulated versions that you can print out and connect with just off-the-shelf tubes. But then when you're ready to actually put them into an object, you can basically drag them around, cut them out, and print your device all at once. We did a whole bunch of experiments, but the TLDR of them is that low speed is better. Lower airflow is actually easier for these devices to compute with. Bigger curves is better, no surprise there. And printing orientation is complicated, so those of you who have used a 3D printer know that the layers are sort of stacked up on each other, and that can really interfere with our smooth airflow. But the devices do work. So we built some things that show it off. So this puzzle basically calculates whether you've put all 4 blocks in the correct order. I have it up here if you want to look at it later, and it pops up a pin if you did. We've got a splitter steal game. So if 2 players decide to split, then the money falls in the box for them to split. But if one player decides to steal, then the money blows in the air for them to collect. We also tried out putting different stuff on our 3D printed devices. So this is basically the bunny, but carved down just into the smart parts, and then we modeled over it with Play-Doh. We've got a pitch slider. So this, oh, no sound, too bad. Maybe I'll play it. But basically all of those other examples show working on a huge air compressor that we've got in our lab, and this is to show that we can do it with just lung power. So turbulence is something that we're thinking a lot about. This sort of historical systems dealt with this by making extremely smooth systems that were CNC machined with incredible tolerance, which we cannot do on a 3D printer yet, but soon. There's also obviously a lot of things that electronics can do that this can't do yet. The historical systems did have ways of doing even volatile storage, so they could get the air jets to stick to the wall in one position or the other to store the value of a computation while the system continued running. We're not quite there yet with our systems, but there's lots of other sensors and more inspiration from this past literature that we think we could adapt. We do, however, still have advantages versus electronics. So as noted, our systems do not care about getting wet. The electronics system would not like this too much, but here it doesn't matter. We can also think about places where electrical power might be hard to come by. So we were thinking about like in a national park system, you could run this. We use air power, but you could use any fluid power. So we talked about running this off of like a river flow. There's also interesting ways to fabricate these. So I also have a laser cut example, if you want to look at that. But at the end of the day, I really just love making stuff. So I'm really excited to be here at DIKU, thinking about lots of tools that we can give people to help them make things too. And I hope you will play with the system. You can find us on GitHub. Feel free to send me an email. I would also love to show all of you these items at dinner or right now. So thanks.
Thank you very much. We have time for questions. I have one to start with. What kind of equipment or lab facilities do you need or do you have right now, and what on a wish list to have?
Oh man. Well, we have a room full of 3D printers, which is great, especially when you're running on a deadline and you need 27 bunnies and you gotta record everything. We also have a industrial air compressor that's about as high as my hip, which I use, as I said, to power these devices. We've got laser cutters. We've got a CNC machine. There's some nicer 3D printers that I really am looking to get because the resolution of these is not quite where it needs to be yet, but at some point. And then, yeah, there's sort of some 3D scanning and motion capture stuff that we're looking at as well.
A question?
Yeah.
So when the circuits get bigger, I guess the air pressure just falls. So do you have anything like an amplifier or?
Right. So in historical gates, there was a way that they did amplification of signal, especially because as I showed with our AND right now, it really depends on the flows being exactly the same so that it can go straight. So we don't have that yet, but that is possible to do.
Yes. Thank you very, very much.
Yeah.
Thank you everybody that you came today. Lots of people I know from before, new faces as well. Thank you so much, and thank you for those that arranged this arrangement. Thank you, Jakob, for letting us know the good stuff happening at DIKU. The state of affairs was great to hear about. Also great to hear from you, the new researchers that have very interesting research angles. Never thought of it. Bunnies. Bunnies computated by air. And cars, self-driving cars. I'm very much looking forward to. I'm getting older, and I'm looking forward to having a car that can pick me up at my home. And then I only say, drive me to my daughter, and then the car knows where my daughter is.
But it'll be a giant bunny. That's the trouble.
I'm really looking forward to that. I'm also looking forward for your side of research. That is really interesting to see how we can change the ambiguity of how we determine whether something is good or not good for us in training machine learning. And also very interesting to learn about neurodiversity. New word for me, didn't know about that. I know all about diversity in general, but not neurodiversity. So very interesting presentations here. Did I forget anyone? I probably did. I'm so sorry. So I say excuse me for that. What I want to say is something from DIKU Alumni. Actually, this is a DIKU Alumni event which happens every year. But on top of that, we have 3 to 4 more other events that the DIKU Alumni, what do you call it? Host group arranges it. I'm part of that. I'm so nicely called chair of that, but we are actually equal. It's just we needed a chair, so that was me. We are several people in this group. We can accept more people, up to 7 actually. And I would like to encourage everyone here that is not already an alumni in our association, please enroll. It doesn't cost anything. It's sponsored by the Institute. So all the arrangements are free, and sometimes if we need money, then we go and ask Jakob. And actually I don't do that, Inge does it for us. But also I would like to tell you about the next arrangement we have. It's in November 24th. It's a Christmas event. We already had it several times. Very cozy. We also have gløgg, that's a Danish traditional warm drink, and cakes. And we will have an introduction, a perspective about data, AI, metaverse, and data insights from someone who's a speaker and has her own 2 companies, by the way. Her name is Pernille Tranberg. So we are welcoming her to our event, and we are looking forward to hear more about metaverse and digital and data insights. She's very busy she's very preoccupied by ethics. So if you look at her LinkedIn profile, she has actually 2 companies. One of them is data ethics and EU, and another one is the digital insights. So with that, I would like to welcome everybody for dinner and reception.